What is the N8N that has recently gone viral on social media? N8N is a workflow automation tool built on Node.js. It uses a visual drag-and-drop interface. By connecting nodes to nodes, it links applications, APIs, and services, etc. Users can build complex AI automation workflows without writing any basic code. N8N is completely open source. It offers a hosted, online version and a self-hosted deployment version. The hosted version's fees are not cheap. The self-hosted version is completely free and unlocks all advanced feature permissions. Also, N8N's MCP feature currently only supports self-hosted N8N instances. Next, I will detail the complete process to self-host N8N locally via Docker Compose. Related project files can be found on my GitHub for reference. The project structure for deploying N8N via Docker Compose is as follows. Includes Docker Compose configuration file, environment variables configuration file. The N8N data folder is used to store data generated by N8N locally. Because when self-hosting N8N via Docker, by default data is not automatically mounted locally. If you do not explicitly configure a volumes mapping to a local directory, then all configurations and databases will be stored inside the container. Once the container is removed or rebuilt, all data will be lost. Docker's default behavior is to not persist unmounted data. Step 1. Prepare the local directory and create related files. Open a command line tool. Run the following commands in the command line. The project folder and the related files are now created. Step 2. Create the environment variables configuration file. We open the project files in Cursor. In the environment configuration file, add the following configuration. Includes set the time zone to China Mainland Standard Time. Enable basic authentication. Once enabled, accessing the N8N web UI will prompt for username and password. Configure the network port to 5678. Explicitly configure the use of the SQLite database. Note, N8N uses SQLite as its default database. If you don't manually configure a database, it will generate a database SQLite file in the N8N directory. Step 3. Configure the N8N deployment file. Add the following configuration to the Docker Compose YAML file. Configuration file includes the following contents. Specify the Docker Compose syntax version. 3.8 is a relatively new and stable version suitable for Docker 1903+. Defines a service named N8N, representing a container that runs the main N8N process. Use official N8N image. Latest means always pull the newest version. If the container crashes or the host restarts, Docker will automatically restart it unless you manually stop it. Maps the host's N8N port to the container's port 5678. This allows you to access N8N via HTTP localhost port 5678. Enables basic auth to prevent unauthorized access to N8N. Set username and password via the environment file to enhance security. Sets the time zone. Asia Shanghai is China Mainland Standard Time. Ensures your schedule triggers and logs use the correct local time. Informs N8N to use a SQLite database for storage. Sets the external webhook URL for N8N to receive external triggers. For public deployment, this should be changed to a real domain. specifies the server hostname, typically used for constructing webhook URLs. Enables community nodes to access tools. Some community nodes need to core system resources to function properly. I will explain in detail why to configure this when creating the MCP instance in the next video chapter. Persists the data to the local NAN data directory to prevent data loss when containers are removed. This stores the SQLite database, workflows, history, user settings, and other important information. Specifies the network the container runs on, making it easier to communicate with other services. For example, databases, proxies. Creates a Docker bridge network named NANnet for container-to-container communication. Step 4. Start the service. Execute the command in the NAN Docker directory. The first time you run this command, it will pull the NAN image from the Docker server. Step 5. Access NAN interface. Open a browser and visit HTTP localhost port 5678. On first visit, a registration page will pop up. Enter your email, name, and password, and submit register. On first login, NAN will request some questionnaire information, which you can skip. Next, the system will prompt you to obtain a permanent activation code. Click to obtain. NAN official will send an email containing the activation code. Copy the activation code from the email. Return to the activation page, enter the code, and unlock permanent usage of NAN. Step 6. Verify whether SQLite is working. Run the following command. If the database SQLite file appears in the NAN data directory, that indicates SQLite is working properly. In the cursor project directory, you can also see that NAN data folder has generated the database SQLite file. With NAN self-hosting deployed completed, next, I'll build an intelligent agent with the following capabilities. A user sends a query prompt. The agent automatically calls the tablet tool to fetch website content. Use Grok Llama 3 model to analyze content and return query results. Before starting, we need the following preparations. NAN's MCP feature currently only supports self-hosted NAN instances. Earlier, we set the environment variable NAN community package allow tool usage to true in the Docker Compose YAML file. This setting allows community nodes to be used as tools by AI agents. Grok is a company focused on AI interface acceleration. Through its innovative LPU hardware and software platform, Grok accelerates AI interface. Grok provides developers with a limited number of free API trials. Mainstream AI models include the latest Qianwen 3, 32B, DeepSeek R1, Google Gamma, and the Meta Llama series. By creating an API key in the Grok console, you can try the large model APIs for free. Tavily is a search engine designed for AI agents and large language models, particularly optimized for RAG scenarios. Tavily offers a free plan for researchers with 1,000 free API calls per month. After completing the preparation, we'll configure the NAN workflow. Step 1. Install the NAN Nodes MCP community node. NAN Nodes MCP is an NAN community node. It allows AI models in NAN to interact with external services via the MCP protocol. Its open source nature and active community make it an important tool for NAN users developing AI agents. In the NAN interface, navigate to Settings, Community Nodes. In the Install Community Node field, enter NAN node MCP. Wait a while, and the node will install automatically. Also, according to official instructions, to enable community nodes in NAN, you need to set the NAN community packages allow to usage environment variable in Docker Compose YAML and set it to true. Step 2. Create the workflow and add the chat trigger node. On the NAN homepage, click Create Workflow to create a new workflow. Create the first node, search for the chat trigger node, and use it as a trigger node. Step 3. Create the AI agent. Next, create an AI agent node. Prompt user message configure as shown in the video. Receive the message sent by the chat node. Configure chat model options. Click the plus below chat model. Select the Grok chat model. Click Create New Credential. Paste the previously created Grok API key. After connecting successfully, you can select the model provided by Grok. Here choose Llama 3.3 70B. Leave the memory option empty. Connect to the Tavily MCP service. Click the plus below Tool. Search for MCP Client tool. This tool is installed via the NAN nodes MCP community nodes. In the configuration box, for credential to connect with, choose Create New Credential. Here, 3 configuration methods are provided. According to the NAN nodes MCP documentation, we choose the stdio configuration method. For the MCP service, select the Model Context Protocol Servers Resource Collection on GitHub. Configure the ListTools node in the Servers Resource Collection from the Tavily service. According to the documentation, set command to npx, set argument to -y plus the Tavily service name. Environment configuration. First paste Tavily API key in the input box. Click expression, append an equal sign after the parameter name, and paste the previously obtained Tavily API key. Click Save, rename the credential to MCP Tavily. Return to the previous configuration page. Keep tool description on the default automatic option. Keep operation as ListTools. Rename this node to ListTools node, then return to the workflow page. In the chat input box, type the prompt, "What tools are available?" The LLM will submit the query to the Tavily MCP server and returns a list of available tools. Configure the ExecTool node. Copy the ListTools node. Double-click to configure. Rename the node to ExecTool node. Change the operation to ExecTool. Set tool name to the expression shown in the video. For tool parameters, click the Start button on the right. Let the large model decide which tool to use and the query parameters. Return to the workflow page and connect with the AI agent. Configure the AI agent system prompt. Finally, double-click the AI agent. In Options, add the system message field and enter the following prompt. The system prompt sets the AI agent's behavior. Use Tavily for web search. Execute the workflow in the set order. First, query and select available tools by the ListTools node according to the requirement. Then go to the ExecTool node to perform the specific search task and return results. Testing. In the chat box, enter "Find me some cave in Beijing." Wait for the workflow to run, and you'll see the returned query results. Understand the workflow by logs. The log records can help us better understand the example workflow. First, the chat node sends the query prompt to the AI agent. After receiving the trigger, the AI model follows the system settings. First, call the ListTools node, which returned 4 available tools provided by the Tavily MCP server. Next, The AI model selected the tablet search tool and requested the exact tool node to query the top 10 caves in Beijing in 2024 and return 10 query results. Finally, the exact tool node returns the retrieved data to the AI model for processing, and the model output readable query results. That's all. Through the Docker self-hosting deployment process and a simple workflow example, we take a peek into NAN's basic capabilities. NAN is very powerful and has a steep learning curve. Look forward to your deeper exploration.